Hey guys, so welcome back to your next class of Catalyst concepts. In the previous class, we learned about what is something called potential difference. So, and we know that potential difference gets set up whenever you connect your conductors to a power source, right? So today we'll look at what exactly is happening inside of that power source that actually makes this potential difference happen. Okay, essentially we are going to be talking today about how a battery works. Okay, we'll talk specifically about batteries and we'll say how batteries work is one thing we talk about today. All right, now all of us have looked at a battery, right? We have seen it in our daily life. We use it for all of our devices, right? Your remotes and whatnot. So it looks kind of like this. You have a small bulb at the front and a flat surface at the back, right? Somewhere over here, you will see a plus written and over here, you will see a minus written. This is how the typical battery looks. Now, we'll try to understand what exactly is happening inside of this battery. Okay, so inside the battery, there are essentially two main components. Okay, there are two major components inside of a battery. Okay? One of them is nothing but a metal plates. Okay, these are basically just sheets of metal. They are at one on this end, one on that end. All right, so one would be your positive and one would be your negative plate. All right, what exactly is this plate? We'll see in a while. Okay, now between these plates within the space of the battery is some sort of a chemical gel. Okay, it's some sort of a chemical gel. The type of chemical will differ based on which battery you are using. Okay, there's like different types of batteries. You'll have batteries with mercury, you'll have nickel cadmium batteries, whatnot. Okay, now no matter what type of chemical it is, essentially what happens in this chemical is there is a sort of a chemical reaction that happens. Okay, now because of that chemical reaction, within this chemical you have different types of particles. Okay, essentially you have positive particles, basically positive ions, and you'll have also negative ions, basically just a big clump of positive and negative particles or ions. Okay, now due to this chemical reaction, something happens to these ions. Okay, so because of this reaction, we say there's something called a chemical force that is generated due to the reactions inside. What this chemical force will do is we'll just call it FC with a small c, meaning chemical force. What chemical force does is it will push ions to one side. Okay, it's going to push the ions towards one side. And when I say push them, I mean push them by separating them. Okay, so all the positive ions are going to be pushed towards the positive. Okay, so slowly what happens is these positive ions will start to gather here and the negative ions will start to gather on the opposite plate. All right, so this is what the chemical force will do, making the ions separate towards extreme ends. However, since these are particles, they have their own force also, right? We know that if you put too many similar charges together, they won't stick. They repel each other, right? If you try to like combine north and north magnet, like how you see, they try to push each other. Same goes for charges also, right? Like charges will repel. So this battery can only do so much. Okay, let's call this force of these atoms or these ions as electric force. Okay, Fe, some sort of an electric force. Now this electric force is generally not very strong. Okay, it's not very strong. Chemical force is usually quite strong. Okay, when the electric force will get strong is if a lot of these ions are clumped together on one side. Okay, so let's say that few ions are there over here. Electric force is not as big as the chemical force. Okay, chemical force is still driving ions to different sides. Okay, but at some point of time what will happen is there will be a stage where there's so many charges over here and so many charges over here that they also try to push back against each other. Okay, they'll try to push away from each other. Because of that, what happens, we can say that the electric force kind of becomes equal to the chemical force. Okay, there are still other ions in between. Okay, there will be other ions that are there in between, but they are just not being pushed anywhere because both of the forces are equal. So if you push in two different directions with the same force, nothing moves, right? So you'll have different ions floating in different places. Okay, inactive, motionless. This is what we call as both the forces becoming equal. This is basically the state of a new battery. Okay, so when you get a new battery, this is how it is. Okay, this there will be all positive ions on one, not all, a lot of positives on one side, a lot of negatives on one side, remaining just suspended in between. Okay, now what happens over here is because of this stage, it has a certain strength. Okay, this strength is what is used when we connect a conductor. Okay, so now assume that to this battery I'm going to connect a wire. Okay, kind of like this with a bulb or whatever it is. Okay, now we know our conductors or wires, let me just call it wires because it's simple. When we touch our wires to this, we know our wires are made of metal, and we know that our metals have a lot of free electrons in them. Okay, so what happens is right now one end of my wire, this end is touching the an area that is completely positive, and this end is touching an area that is completely negative. Correct? So if you see, it's like you having two hands, one hand you put in hot water, one hand you put in cold water. There's a difference, right? So this is what the conductor is feeling. One side is too positive, one side is too negative. So what is going to happen is these electrons will feel a sort of a push or a movement simply because of the negative charge over on this plate. Okay, on this side, negative pushes negative. We know electrons are negative, right? So they'll push the electrons away from here. Okay, so they'll go in the opposite direction of this negative plate, and at the same time over here these are positive, right? And the electrons are negative, so they attract to the positive. So the electrons try to enter the battery from the positive plate. Understood? So what happens over here is essentially this. The moment you touch conductor to the wire, the electron flow starts from this end to this end, from this end of the conductor to this end. All right. We know that this is the direction of electric field from positive to negative, but because of the nature of charge, electrons come from negative to positive side. Okay. So the moment they enter this positive, negative, positive meet. A positive ion gets an electron. Because of that, what happens is it's going to become neutralized. Okay, so now what happened is say some positive charge is gone. Okay. Because of this, the electric force has reduced again. Okay, because the number of ions on one side is done or reduced. So electric force becomes weak and chemical force is again strong. So what the chemical force will try to do is it will try to push out one negative atom, negative particle to balance the flow. Okay, since the positive has decreased by 1, it will try to reduce the negative also by 1. Okay, so it will start to push all or uh, any or all negative particles to the other side to send them outside. Okay, but these ions cannot go out. Okay, instead what it does is it will send out an electron from that side. Okay, it will send out an electron from the other side. So what happened? One positive charge is gone, one negative charge is also gone. Okay, essentially the amount of charge is still the same. There is some positive and that much amount of negative. If one positive is gone, one negative is also gone. So again, once that happens, again the chemical force and electric force will become equal. Okay, they again come in balance. So the way you see it, every time an electron enters the battery, one electron will exit the battery. Okay, that is how that balance is maintained. And this is a continuous loop of electrons always entering, okay, entering the battery from positive end and coming out of the negative end. Okay, so this means that at any moment, the number of electrons in my wire or conductor is always the same. Okay, it doesn't matter how long this thing has been running. Okay, because for every electron coming in, there's an electron going out. So we say that the electrons are not changing in the metals. Okay. So this is the working of a battery. Now, what happens over time is, since a lot of these ions get you get neutralized, and also the chemicals that are inside of this battery, right? The chemical reactions don't last forever. Over time, the chemical force will become weak. Okay, it will become so weak that it cannot push these ions to the wall anymore, right? If those ions are not being pushed on the wall, the positive charge is not created, because that means electrons won't come. So your weak batteries, if you see, the current is low because the amount of positive charge is very low, so the attraction is very less, so the energy flow is also very less. Okay, that is why weak batteries don't will give you like dim lights and all, and ultimately it will stop because the chemical force is completely gone weak. All right. Yes. So this is how the battery works. All right. Certain names I should tell you. This negative plate is called as cathode, and the positive plate is called as anode. Okay. Not really that necessary, but yeah, something you should know. Okay. So the positive ions all at anode, negative ions all at their cathode. So this is all for today. I hope you understood. If you have doubts, please put them down in the comments below. And I'll see you guys again in the next class. Thank you.